All right, I think we'll get started. So, welcome everyone to Everest Labs webinar, Cut Costs and Boost Recovery, real world success stories with AI and robotics. Before we get started, there are a few things I want to go over. First, everyone is muted. Second, we will be recording the webinar and we will be sending that recording to you in the upcoming few days, so look out for that email. And lastly, we will have a live Q&A at the end. So please feel free to put your questions in the Q&A box at the bottom of your Zoom screen. So hello, I am McKenna Phillips. I am a marketing specialist here at Everest Labs, and I will be presenting alongside Catherine Nellis, solutions engineer at Everest Labs as well. So for our agenda today, we are going to start by walking you through an overview of our Recycle OS system. And then we're going to go over 4 different customer case studies, and we will end with our live Q&A. And with that, I will pass it over to Katie.
Okay, thanks, McKenna. So Recycle OS is the name of our platform and our solutions that we provide to different types of recyclers in the industry. It begins with our vision system, which is a camera that's mounted on top of your conveyor belts. It's self-lighted, and it captures every visible object that passes under the camera. So that creates a digitized material stream that is then applied to our AI, which is our image and text recognition and machine learning models. These models decide, identify, and classify the stream into 60 different object types with incredible accuracy and in milliseconds, thus creating a complete data set of all of the materials flowing in and out of your plants. This data can then be used in a few ways. Recycle OS can be installed as a standalone camera system where the data is leveraged to identify plant improvements and more. But the AI and data can also be used to instruct our robotic arms to then increase recovery and automate your sorting needs. Lastly, all of that data is converted into analytics on customizable dashboards, which allow operators to get real-time insights through a cloud-based platform or in automated reports that can be sent directly to your operators and your MRF managers. But regardless of the solution type that's deployed, we aim for our installments to be as hands-off as possible. So we staff a remote robotic operations center that uses software programs and humans to monitor your solutions 24/7. These programs are constantly auditing both our model and robotic performance, alerting your teams if there are any issues, and all of this is to reduce downtime and alleviate folks from having to babysit our systems or to perform a lot of maintenance. In fact, our daily maintenance only takes less than a few minutes. Next slide, please. So here is who we work with throughout the entire recycling chain. I'm going to start with the material recovery facilities or MRFs in green here, which are the majority of the customers that we service today. MRFs, of course, process and sort residential and commercial waste. Our AI is used all over their facilities to monitor their operations and provide valuable data. They also use our robotics to automate their manual sorting on quality control lines, like removing contaminants. And our robotics are also very successful on residue or last chance lines, which allow MRFs to increase revenue by recovering more recyclables from being sent to landfill. Next on the chain, we have reclaimers or recyclers who purchase sorted materials from MRFs and actually recycle aluminum, paper, plastics. These reclaimers make up the other highest percentage of our customers who use Recycle OS. They leverage our AI to monitor their in-feed supply and quantify the level of contamination in the bales that they're buying from MRFs. And they also use our robotics to clean up that material stream and allows them to produce the highest possible yield. On the packaging side of the business, our AI can provide data that is useful for audits, for supplementing life cycle analysis of a product or a packaging class, and also to track where those products actually end up at their end of life. So we can partner with packaging manufacturers to deploy our systems and provide them this data. Another interesting subset on this chain are some self-contained facilities like college campuses or arenas and stadiums that generate large amounts of waste and are looking for technology to manage that in-house. So our AI and robotics can provide on-site separation for them. And lastly, brands. Strategically placing our cameras and our AI across regions can provide really valuable data on product consumption, data for regulatory compliance, and overall huge insights into how circular and how recyclable these brands and their products actually are. Next slide, please. Okay, so we're not the first AI and robotics company in this space, but I can say with confidence that we're at the top of the list, and these are some reasons why. Um, First, we're simple. Our small footprint cameras and robot can be installed without retrofits. Unlike other robots in the industry, our robot arm is a 6-axis FANUC arm that you can see here. It mounts directly next to a conveyor, like where a human sorter would stand, and it's designed to only take up that amount of space. This means we can install on both flat and inclined conveyors. It doesn't matter. We're dependable. We come with that robotic ops center I mentioned that guarantees our robot uptime and our performance. And this level of service is what we're especially proud of in that access to your data, to suction cups, to our engineers, our robotic ops center, our customer success team, it's all included in the subscription that you have with us. And we're precise. Our AI and imaging is top of class, and we're continuing to improve it as our footprint and our database of objects continues to grow. And with that AI being configurable in nature, it allows our solutions to evolve kind of in lockstep with changes that are happening in the industry, like new packaging, new recyclability rules, and even EPR mandates. Lastly, and most importantly, our payback periods for plants of certain volumes and operations is quick and impressive, often anywhere from 3 to 6 months. A large part of that is our ability to get installation done quickly and efficiently. Shout out to our deployment engineers who work on weekends and during your off shifts to get those done without disrupting your normal processing hours. So that's a bit about Everest Labs and what we have to offer. Next slide.
Great, I will take it over from here. Thanks, Katie. So for our first case study, we are going to visit a MRF in the Pacific Northwest. This MRF wanted to know the volume, value, and types of material they were losing to landfill from their last chance line and wanted to use this data to find ways to help increase material recovery. After looking at different options and speaking with Everest Labs, they decided to implement our AI vision system on their last chance line, which you can see in the picture on this slide. And after having the vision system up and running for just over a month, they were really stunned to learn just how much money and material they were actually losing to landfill from their last chance line. So they found that they were losing around $43,300 monthly. So they had access to this great data showing them the types of material they were losing and how much it was worth, but the question is what to do with it. By having this real-time data and visibility into what was ending up on their last chance line, their plant general manager was able to make some data-driven decisions on what needed to be optimized upstream in their facility to increase material recovery. So what did they do exactly? They decided to systematically adjust their eddy current separator and optical sorter settings to increase material recovery. And they also placed a manual sorter on the aluminum line after the optical sorter. So after these changes, they were able to decrease their monthly material losses from $43,000 to $15,000, saving them around $28,300 monthly and $336,000 annually. And by adding robots, they could decrease these losses even more. So, as we all know, material conditions are constantly evolving in recycling facilities. No load of collected material will ever be the same. So, having access to data on an ongoing basis has been proven to be invaluable to the Smurf. This data helps them continually optimize their machinery, enabling them to be more profitable and divert what would go to landfill back in the circular economy. Next slide, please.
Awesome. Thanks, McKenna. This case study on how to utilize data to assess staffing comes from a mid-sized MRF in the mid-Atlantic region of the US, processing around 170 tons per day. No shocker to anybody in the industry that labor is one of the highest costs at a MRF, and this particular MRF had been struggling with labor sourcing and high turnover since the pandemic. In their MRF, they have a long flat conveyor towards the end of their material flow that's kind of like a container line, but it also acts as their last chance line. And there's a platform on one side where sorters stand, and then across from that conveyor, there are bunkers for the different plastics and UBC. So prior to our project with them, they were staffing 5 contract sorters on the line, and they chose to install our RecycleOS camera system at the beginning of the line. With that data, they were able to categorize all the recyclables making it to that conveyor, and more importantly, for materials like PET, HDPE, UBC, they used our analytics to calculate the dollar value of the material on that container line. And what they found was that there actually wasn't enough material value there to justify the 5 sorters to stand there and actually recover it. Since then, they've chosen to replace those 5 sorters with 3 Everest Lab robots, which will allow them to maintain recovery of the material while saving on labor costs. Another cool fact about this facility and the solution is that we are installing the robots actually on the bunker side of the conveyor belt, which allows the team to maintain safe egress on the existing platform where they do a lot of maintenance. This just highlights how flexible our small footprint robots are and how creative we can get with our applications. Next slide. All right, tuning equipment and using robots to recover UBC. This study comes from Lakeshore Recycling in Chicago, specifically their Exchange MRF. It's an impressive operation that runs 24/7 or maybe 24/6. They process nearly 500 tons per day, and they're expecting to only ramp up that volume in the future. So they had been observing that a lot of UBC, a lot of aluminum cans were being sent to landfill, and they actually partnered with the Can Manufacturing Institute for a grant that they used to install one of our Everest Lab robots onto their last chance line. We put the robot directly across from their UBC bunker and used it to recover additional UBC from being sent to landfill. However, with the data and analytics from the camera system that's there and is used to inform the robot, they were able to deduce that the issues with all the UBC ending up on the last chance line was actually due to their eddy current underperforming. So in their MRF stream, there is an eddy current that is supposed to divert all that UBC out of the stream before the material passes onto that last chance line where our robot is. And this data allowed them to justify the necessary equipment needs to fix and to tune that eddy current so that it became more effective at actually diverting the UBC out of the stream. And what's great is that after those eddy current changes were made, a lot less UBC ended up making it to the last chance line. But because our robot was installed to pick UBC, we said, hey, now that robot actually has a lot more available picks per minute. So we updated our configurable models to now instruct the robot to begin recovering other valuable materials like HDPE natural in addition to any aluminum cans. So in 2024, the robot recovered over 1.3 million aluminum cans only, and that's not even including any HDPE natural it's grabbing. And it's still recovering around 600,000 cans quarterly. And I love this story because it shows how powerful the data can be in allowing MRF operators to improve not just what is happening on a sort line where the camera is, but make improvements all throughout the MRF, using that data to actually calibrate and tune their other equipment. Next slide. Alrighty, last but not at all least, integrating Recycle OS to control throughput and yield. This case study is not about a MRF, but actually a plastics recycler. So they're running nearly 24/7, processing primarily PET. And they were already using our robotics on their PET QC lines. One robot was installed on their clear PET QC to remove any contaminants or any colored PET. And kind of inversely, another robot was installed on their green PET line to also remove contaminants. So as big users of our Recycle OS already, they actually decided to further utilize the data to help inform their other processes in the plant. So we built an integration, a secure data transfer for contaminants per minute. And that and we took that data point from the on-site compute box, and in real time, we're able to send counts of those contaminants per minute to their in-house analytics tool that they use in tandem with their other machinery. So why is this useful? Why is this cool? Well, in a plastics recycling plant, they're all about having a high throughput, which is how much material they're processing. But at the same time, it's also critical that they maintain a high yield on the output of the PET flakes and the recycled content that then they are sending out to their customers. So the PET stream passes through the QC area where our camera and our robots are, and then goes into other equipment like wash lines and more. And those machines are greatly impacted by the purity of the stream that enters it. So this client, they have their own thresholds set in their processing, like 10 contaminants per minute or 100 parts per million. And using the data from our cameras, they can be alerted if that threshold is met. Then they can stop the line or they can divert the stream from going into the wash process and perform additional quality control on it to make sure that it's optimal for further recycling. And this really just allows them to have better control over the quality of their end feedstock. And if I didn't already mention this, the data integration is truly real time, which allows them to act fast and adjust their processing accordingly. So pretty cool stuff.
All right. Oh, excuse me. All right. Thanks, Katie. So, now we can go ahead and do some Q&A. So go ahead and pop any questions in the Q&A button at the bottom of your Zoom window, and we will get started. All right, so for our first question that came in, they want to know how long does it take to start seeing data after the vision system is deployed? Katie, I'll go ahead and pass that to you.
Yeah. So the moment a vision system is mounted and turned on and connected, we're collecting data. So any material that's passing under it, we're seeing it, we're categorizing it. So the data capture is immediate, and all that data from the compute box where it's stored on site is uploaded nightly to our cloud. So from day one, our out-of-the-box model is then fine-tuned to the exact solution and line that it's put on. So over the course of a week or two, we're identifying at over 95% accuracy. And that's when, you'll have a couple of weeks worth of data and then you can start gleaning some really cool analytics from it.
Awesome. And just a reminder, if you have a question, go ahead and put that in the Q&A at the bottom of your screen. Let's see. So the next question, what are some examples of the types of data recycling facilities receive from RecycleOS? I can go ahead and take that. So we provide our customers with a bunch of different types of data. We give them the material composition of their recycling line, the contamination percentage, the value of recyclables we're seeing on their line, and we can also do mass balancing and volume estimates. We also provide a lot of different recovery analytics. So we can report on the efficiency of optical sorters, the recovery rates of commodities, the volume and value of materials that are being sent to landfill from your residue line, and also avoidable disposal or landfill costs. And kind of going back to this material characterization, material composition data, because we're able to collect this, we can also do material audits for compliance reporting. And this is going to be especially important as EPR legislation comes into play. So yeah, that's some of the data we provide. For the next question, are there any cost implications that you can share for the robotic arm? Katie, do you have any thoughts on that?
Yeah, so we offer, and forgive me, I'm not our pricing expert, but we offer both lease and purchase options for our equipment. So the robotic arm can be anywhere from about 65,000, give or take a little bit. And then there is also a subscription for our services and our data and kind of everything that is included in that. That's around, I would say, $25,000 a year. And that I'm seeing another question kind of about maintenance being included in the subscription. So I can answer that one in tandem here as well. The answer is yes. So our maintenance is very minimal. We suggest to our clients using our robotics that once a shift, if they're running multiple shifts, or once a day, to use like a stiff brush to actually clean out the end of arm tool, and then to replace the suction cups, because we use suction cups and they are provided in the subscription. So we send as many as you need, and we'll replace them when you start to run low. So we suggest that you pop those off and replace them, once a shift as well, or of course if there is any tear in it. So yeah, the maintenance is minimal, and any repair, of course, we would address immediately. We would try to, if there's any issues, solve them remotely with our robotic ops center. If not, we will send one of our engineers out to help fix it.
Awesome. Okay, we have a bunch of questions that I think, Katie, you're going to be the best to take on. So let's start with for the LRS analysis, how long did you collect the data to inform facility changes?
Yeah, so I think it was our standard deployment process. So just a matter of a couple of weeks. So how we handle our standard deployments is to, once all of the site prep is ready, so that's things like dropping power lines, having internet connection. Once the vision is installed, which takes about a day, And again, we work on your off schedule. So we're not, we don't need to stop processing in order to install this. So then, yeah, we gathered data for, I think, a couple of weeks, I think maybe 3 weeks maximum. And then we installed the robot after that. And yeah, just with kind of that first month of data was sort of, I mean, they knew that they were losing a lot of UVC already, but having the actual numbers and kind of the dollar value associated with that, it allowed them to act fast and be like, okay, we need to address our eddy current issues and fix this.
Awesome. And then you kind of touched on this, but the next question is what power requirements should be considered when installing the robotic sorting system?
What power requirements should be considered? I'm trying to remember the specs. Our vision systems require, give me 1 second, I'm just pulling up my numbers. It's pretty standard plugs. I think we ask for 110 for the camera and 220 for the robot in terms of voltage. Most facilities don't have any issues with the power drops. In order for our systems to be connected to our cloud, we do require an internet connection, typically wired, so Ethernet. But what's cool is that internet is not required in order for our systems to function. It's really just how we stay connected so that we have the data in our cloud, as well as our robotic operations center has, the eyes on the system. But, we've had plants that are running and, they lose internet for whatever, and the systems still function. It's just, a matter of the data is this stays on site in that case.
Perfect. Next question. What are the most difficult materials to identify?
That is a good question. Like I mentioned, we're pretty top of the line with our model recognition, using both image and text to identify the features of a particular object. I know in comparison to other sort of material detection equipment, we do well at some of the more difficult materials like black plastics. Most conveyor belts are black, so sometimes some equipment can find it difficult to identify them, but we've made a lot of progress in that. I'm trying to think of some other ones. What's cool is that materials like polypropylene cups that may look like PET but are actually polypro. We've made progress on being able to identify the differences there using feature sets. And, packaging wrapping also can make it difficult for other, NIR technologies that the bottle might be PET, but it might be wrapped in something else. And we're able to, use our camera and our vision system to say, no, that's actually a PET bottle, and we should recover that and things like that.
And then, do we have anything in the UK right now? We do not, but we will be at RWM, Resource and Waste Management Expo in September, which is in the UK. So when we have more details, we will start sending that out. But just to note, to come visit us when we're there. Awesome. Next question. Is the data provided in number of pieces or by weight? Katie?
Yeah, I can answer that. So we do both. We do object counts as well as mass estimates. So for more standardized size and shape and volume materials like aluminum cans, HDP, PET, we can identify the counts of objects, but also the estimated tonnage. So weight as well, yeah.
Perfect. Next question, is the robotic sorting system able to recognize LDPE film material? And if
Yes.
yes, can you share the recovery rate and accuracy?
Yes. So yes, we absolutely can identify LDPE, those films. I mean, there's a thousand different types of plastics and light films that people are seeing in their facilities. I don't have a any sort of recovery rate off the top of my head, but I can say that we do have applications where our robotics are removing film contaminants off of the line.
Perfect. Let's see, what else do we have? Can a MRF operator be able to train the system to recognize new materials over time, or does it have to be done with our staff?
Yeah, great question. The answer there would definitely be to be working with us. So it's actually a cool process. We do it a lot with our operators in that we pick a time, pick a day, when you're running a certain supplier's material, and we're able to sort of timestamp that, what we would call like an audit or a test, and allow our engineers to go through, test the model accuracy at identifying a new object or a new material stream that you might be testing out. And yeah, then we can see the accuracy and kind of the confidence rate on those identifications that the model is making. And it only takes about, it takes about 10,000 instances of a new object for our model to be fully trained on it. And in the event where, maybe it's a rare or not as common object that you're seeing, but we want to train our model on it, even if you only have a few thousand instances of that object on the belt, we can use that data and then actually generate data off of that to continue to train the model on. Obviously, it's ideal to see the full 10,000 instances in a real situation, but we can supplement that data if we need to.
Awesome. So we're actually going to wrap it up. There are a few more questions that we will go ahead and reach out to you directly. And yeah, thank you to everyone who joined this webinar today. Again, I will be sending out the recording in the next few days, so keep an eye out, and we hope you have a good rest of your day. Thank you.